Imagine two electric heaters. One is 600 watts. The other is 1,800 watts. You turn both on in a cold room. Which one heats the room faster? Obviously the 1,800 watt heater. But why? What does that number actually mean? To answer that, we need to understand two ideas that run almost everything in our world: energy and power. And once you understand the difference, a lot of things suddenly make sense, from microwave ovens to wind turbines to electric cars. First, let's talk about energy. Energy is what makes things happen. A tiny pulse of electricity inside your phone? That's energy. The heat from a stove? Energy. Even a huge explosion releases energy. In physics, energy is measured in a unit called joules. You can think of energy as fuel for actions. Without energy, nothing moves. Nothing heats up. Nothing changes. But energy alone doesn't tell the whole story. Because sometimes what matters is how fast that energy is used. And that's where power comes in. Power simply means the rate at which energy is used or converted. In simple terms, power equals energy divided by time. So power answers the question: how quickly is energy doing work? Think of it like pouring water from a bottle. If you pour 1 liter of water in 1 second, that's a strong flow. If you pour 1 liter over 10 seconds, the flow is weaker. Same water. Different power. The same thing happens with machines. An 1,800 watt heater converts heat energy 3 times faster than a 600 watt heater. That's why the higher power heater warms the room much faster. Power is measured in watts. And 1 watt simply means 1 joule of energy used every second. Interestingly, the word power can mean two slightly different things. Sometimes it describes how much power something produces. Other times it describes how much power something consumes. For example, a power plant produces electricity. A microwave oven consumes electricity. Both are measured in watts, but their roles are different. Let's look at some real-world examples. A nuclear power station can generate about 1,000 megawatts of power. That's 1 billion watts. Enough electricity to power a large city. A typical offshore wind turbine produces around 3.5 megawatts. That's enough electricity for about 1,000 homes. Now compare that to something in your kitchen. A microwave oven usually uses about 1,000 watts. That's tiny compared to a power plant, but still powerful enough to heat food in seconds. A typical LED television uses only about 60 watts. But since we watch TV for many hours, its yearly energy use can end up similar to a microwave. This shows something interesting. Even devices with low power can use a lot of energy over time. Power also matters in transportation. For example, many electric cars have motors around 147 horsepower. That might sound lower than some gasoline engines. But electric motors have a special advantage. They produce maximum torque immediately, even when the car is standing still. That's why many electric cars feel very fast when accelerating. So power isn't just about big numbers, it's about how efficiently energy is delivered. So here's the key idea. Energy is the ability to make things happen. Power is how fast that energy is used. Energy is the fuel. Power is the speed of using that fuel. From nuclear power plants, to wind turbines, to microwaves, to electric cars. Our modern world runs on the relationship between energy and power. And once you understand that difference, you start seeing it everywhere.